Good morning, everybody. Thank you for coming so early in the morning. I hope I help you start the day well. And we're going to serve some refreshment for you. We're going to talk about ice sheets in Greenland and Antarctica. And it's a hot topic of research. It's a very exciting area of research right now. I know sometimes my wife tells me, why don't you slow down a little bit in your work? And I wish I could sometimes, but unfortunately there's so much excitement in studying the polar regions, thanks to climate warming, that I just can't rest quite yet. I have some of my colleagues who tell me I should be retiring, but I've been waiting for this all my life, so I'm not going to retire. This is also a field where scientific knowledge is changing rapidly. When I mean rapidly, I don't even mean year by year. I mean month by month, or even the paper that came out last week. And some of these results really shatter what we thought we knew about ice sheets. What we thought we knew about ice sheets is shown here, this IPCC statement from 2001. We thought that as climate gets warmer, of course the ice sheets are going to melt a little bit at the periphery, but there's also more evaporation from the ocean, and thereby there's more precipitation on the ice sheets, especially in Antarctica, because Antarctica is so cold. You have to warm up the climate by 5 degrees before it starts melting. So in the meantime, it can only grow from enhanced precipitation. And this was still the state of knowledge just a few years ago. Now this view graph, sorry, the view graph should show a little bit better, but it's a little bit too bright here. But the challenge of studying these ice sheets is quite large. This is Antarctica. It's about 40% bigger than the United States. And there's about 15 centimeters of water falling on it every year. So you want to find out if a place like this, which is like a desert, is growing or shrinking with time. 15 centimeters of water every year over an area bigger than the United States. And there's enough ice in Antarctica to raise sea level by 60 meters if it was all going to melt in the ocean. Greenland is about 7 to 8 times smaller, 7 meters of global water sea level locked in the Greenland ice sheet. These ice sheets have been melting away since the last glacial maximum, and they've been doing that at different rates. They're melting away today, but as a glaciologist, I'm not so worried about the type of melting they're doing today. I'm worried about what they did, for instance, 12,000 years ago, when sea level was rising 50 millimeters per year, which is about 20 times faster than what it's doing today. And this is due by this is caused by ice sheets. There's no other processes on the surface of the Earth that can cause sea level to rise as fast as that. How do you form an ice sheet? It forms from snowfall that densifies into ice very slowly, and when ice is thick enough, it deforms under its own weight, like a viscous fluid, a viscous solid, I would say, near its point of fusion. And it flows down to the low-lying regions where it might melt because the climate is warmer. It can flow down to the ocean and interact with the ocean and form these floating extensions that we call floating ice shelves. Now, in this cartoon, the flow looks like it's fairly uniform, like a big ice cube deforming uniformly around its periphery. It's not like that in reality. It's an organized flow where ice is being channelized through river systems, which we call glaciers and ice streams. And these are fairly narrow features that drain very, very large basins.